All right, so today we're going to talk a little bit about average rate of change and instantaneous rate of change. And these are definitely big topics, foundational topics, because calculus you can really think of as the study of change. And so as you go about your daily life the next few days, every time you see something changing in any way whatsoever, you can really think that there is some calculus happening in the background, or maybe not so much in the background. And as we think about measuring change and studying how fast something is changing and what happens when that change happens over time, we're really doing some calculus. And so the two big ideas are average rate of change, and this actually isn't a calculus concept, it's algebra concept. It's basically a slope formula, which may look familiar to you. So average rate of change is the change in something. The sort of standard example is position, but as we'll see, it can be lots of other things divided by the change in something else. And again, most of the time, a lot of the time, that denominator is a time unit, but it can be other things, as we'll see as well. And so it's change in something over change in something else, change in position over change in time. And the sort of algebraic formula is basically the change in y over the change in x. As I said, sort of the good old slope formula. And so when we look at a picture like this, if I'm looking at a parabola and I sort of want to know the average rate of change between these 2 points, I'm basically looking at the slope of the line between those 2 points. And so we're looking at the change in y, and so how much do these y coordinates change? And so this is the change in the 2 y coordinates, so f of b minus f of a, and let me get that on the screen there. And then the change in x is just b minus a. And so this is the point b comma f of b. So f of b is the y coordinate. This is the point a comma f of a. And then we just did the change in y over the change in x, as we had back on this slide. Example would be if you are driving somewhere and you know that you drove 50 miles in 1 hour, your average rate of change for that hour would of course be 50 miles per hour. You don't need to know how fast you're going at any particular time. You just know that your overall change in position was 50 miles. Your change in time was 1 hour, and so your rate of change, your average rate of change, is 50 miles per hour. As we're doing these problems, little quick side note, as we're doing these problems, there will typically be used a thing called interval notation, which you might be familiar with from before. It's sort of a companion with inequalities, and really on the AP test, and I will accept both of these, but you definitely want to understand both of them. And if you choose to write it one way or another on a test or a quiz, that's fine. And so bracket we consider to be closed, the endpoint is included. Parenthesis we consider to be open, the endpoint is not included. And so a comma b with a bracket on the left and a parenthesis on the right means everything between a and b, including a, but not including b. You can throw infinity into the mix, negative infinity, and so forth. You never put a bracket by infinity. You can never actually equal infinity. It's just more of an idea. And so you put the parenthesis always on infinity or negative infinity. So that'll come up a lot on these problems. It'll say find the average rate of change on the interval from 1 to 3, for example. Second big idea is the instantaneous rate of change. And so we already talked about the average rate of change. It's an algebra concept, change in y over change in x between 2 points. It's that secant line picture that we saw before. The instantaneous rate of change is the calculus concept that we'll be working with a lot over the coming weeks. And it's the change in y over the change in x at a single point. And of course, the problem with this is if you only have a single point, how are you going to do change in y over change in x? You only have one thing to work with. And so the idea is going to be that, if I can get this to work right, is going to be that we're going to look at what we call a tangent line. So it's a line that just grazes the curve at that single point that we're interested in. And so the question is going to be, well, how do we do the slope formula when we only have that one point? How do we find the slope of that tangent line? And we're going to see lots of ways over the coming days about how to get the slope of that tangent line. For now, we're just going to estimate it, and usually we estimate it by just picking another point that's really close to it and doing the slope of the line between those 2 points. And if we pick the 2 points to be close enough to each other, then we'll have a good estimate, at least, even if it's not the exact answer, of the instantaneous rate of change. So IROC is instantaneous rate of change, AROC is average rate of change. And we'll do lots more with this in the coming days.